Good day to all of you. So in this video tutorial, I'm going to illustrate how does this disk scheduling algorithm is done. So for this, I'm going to illustrate the three most commonly used disk scheduling algorithm, which is the Fcfs, or the first come first serve. We have the scan, and last but not the least, we have the C-scan, or circular scan. So actually, there are many disk scheduling algorithms that exist, but of course, I only illustrate these three because these are the most commonly used disk scheduling algorithms, and at the same time, it will not cause starvation problem with regards to the cylinder that is going to be served. So for this example, I got it from geeksforgeeks.org. So as you can see with this one, it is already given in that site, but then again, I'm going to illustrate you how does the disk scheduling algorithm is done. So let me read first the problem. So suppose that a disk drive has 200 cylinders numbered 0 to 199. The drive is currently serving a request at cylinder 50, and it is also given that the disk arm should move towards the larger value. So the queue of pending requests in FIFO order, or the first in first out order, is, so the given values are for the cylinders is 82, 170, 43, 140, 24, 16, and 190. So starting from the current head position, what is the total distance in cylinders that the disk arm moves to satisfy all the pending requests for each of the following disk scheduling algorithms? So of course, the disk scheduling algorithms that we have is the Fcfs, the scan, and the C-scan, as I've mentioned earlier. So let's start with first come first serve, or the Fcfs. Okay, so we have Okay. Fcfs, or the first come first serve. So it means that whatever the sequence of the cylinders, so again, let's return with the problem. So whatever the sequence, we're going to follow the sequence. So actually Fcfs is very easy because we're just going to follow the sequence of the cylinders as listed. Okay, so but before that, let's create a sort of a number line that will show the cylinders. So first is we have, okay, I have a ruler here. Okay, so let's draw. Okay, let's draw. Okay, so we have, it is said the cylinders is up to 200. So from 0 to 199. So we have 0, and then we have 199. Okay, so by means of the given values, so let's have again the values. So let's in this number line, let's have the values in ascending order. So we have 0, and then we have 16, and then we have 24, and then though 50 is not here in the list, since it is stated that the drive is currently serving a request at cylinder 50, let's include 50 later on. So next is we have 0, 16, 24, and then we have 43. And then, as I've said, let's include 50. And then next is we have, next to 50 is we have 82. Okay, 82. Then next to 82 is we have 140. And then next to 140 is we have 170. And then next is we have 190. Okay, so we already have a number line again. So Let's count. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8 because of 50. So yeah, you have to be sure that you have the exact value. So it says that the request is currently at 50. So let's just put a mark in here. So as it is said, Fcfs depends on the sequence. So first is we have, okay, we have 82. Okay, we have from 50 going to 82. Okay, so let's have an arrow. Next to 82 is we have 170. So 170 is here. Okay, let's draw a line. Okay, then draw an arrow. Okay, next to 170 is we have 43. So 43 is here, so it's going to go back. Okay. 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 Okay, next is we have 140. So it will go to 140. Okay. 140. Okay, next is we have, next is 24. So it will return to 24. Okay, next is we have 16. So let's just extend it up to 16. Okay, and then next is we have, last but not the least, is we have 190. Okay, so actually first come first serve is the easiest because it will just follow the sequence. Again, we have 82, 170, 43, 140, 24, 16, and 190. So we have this graph. So how are we going to calculate the total number of movements, head movement, or the total seek time? Okay, so we have total seek time, or we have the total head movements. Actually, what you can do is what? So by means of these lines, you can subtract 82 minus 50 and then 140 minus 82. You can do that, but there is an easier technique for that. Instead of subtracting the line segments one per segment, all you have to do is you have to consider this whole line. Instead of example 82 minus 150 or 170 divided by rather minus 82, let's just do 170 minus 50. Actually, they're just the same answer. It's easier. So, what do I mean by that? So, the number of line means that's the total number of subtractions or deductions that you're going to do. Instead of 1, 2, 3, 4, 5, 6, 7. So, we have 1, 2, 3, 4, 5. Only 5 lines. So, first is we have 170. Okay, 170 minus 50 is equal to 120. Okay, so we're already finished with this first line. 170 minus 50. Next is we have 170 minus 43. So 170 minus 43 is equal to 127. Okay, we're already finished with this one. Next is this third line. We have 140 minus 43. So 140 minus 43 is equal to 97. Okay. Next is, okay, we already finished with 140 minus 43. Next is 140 minus 16. Okay, 140 minus 16 is we have 124. Okay. Next is, last but not the least, is we have 190 minus 16. We have 190 minus 16 is equal to 174. Okay. Just not to be confused with my number 7. Okay, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we already have the total, the difference, the 5 differences of the 5 lines. So next is we're going to add this so that you will know the total seek time or head movements for first come first serve, this scheduling algorithm. So we have 7 plus 7 is equal to 14, plus 4 is 18, plus 4 is equal to 22, carry 2, and then 1, 2, 3, 4, 5, 6. 6 plus 9 is we have 15, and then plus 2 is 17, and then 17 plus 7 is we have 24. So 4, carry 2. So 1, 2, 3, 4, 5, 6. So we have 642 total seek time or head movements for first come, first serve. So as you can see, the problem with first come first serve is what if, of course, the sequence of values are not in ascending or descending order. So it will just seek what whichever is first. So that's why, as you can see with our directions, it really goes with the sequence. Okay, so much for first come first serve. So next is we have the scan. Okay, scan is also called the elevator algorithm. So let's get back to our problem. So for the scheduling algorithm, it is said that the cylinder is at the read-write arm is on cylinder 50. So as you can see that there is also this sentence here that it is also given that the disk arm should move towards the larger value. Actually, in first come first serve, it does not this is not applicable, because as you can see again, first come first serve, meaning it will just only follow the sequence or the order of the cylinders that is to be serviced. So for scan and C-scan, we will use this condition. So it means that, so given that the disk arm should move towards the larger value. So example, if you are in cylinder 50, you're not going to the value descending or less than 50. So you'll go for a larger value. So that's why it is said here that towards the larger value. So let me illustrate again about the scan algorithm, or the other term for that is we have elevator algorithm. So again, so we have scan. Okay. So let me have again or create again a number line for that, for this algorithm. So again, let's label 0 and then 199, and then I'm going to repeat again. So we have 16, then we have 24, and then we have 43, and then we have 50, and then next is we have 82, and then we have 140, and then 170, and then last but not the least is we have 190, 1, 2, 3, 4, 5, 6, 7, 8, including the recent or the current request at cylinder 50. So for scan again, we have to identify for this sequence the order of in ascending order starting at cylinder 50. So from this one, so the larger values actually is to, in relation to 50 is 82, 170, 140, and then we have 190. So let's just arrange it in ascending order. So let's have, so okay, we're going to start with 50, and then next is we have the request is on 82. Okay, next is we have 100, 140. Okay. Okay, 140. And next is we have 170. Okay. Next is 190. Okay. So, the only okay, we already plotted all the larger values than the cylinder 50. But the difference with scan with Fcfs, scan will go to the last cylinder, which is 199. So it will go to the end of the disk. So for, going to 199, though it is not included in the values, but then again, that's the rule for scan. And then, since the only remaining values is 43, 24, 43, 24, 16, so it will return to the nearest. Actually, the nearest here is we have 43, and then we have 24, and then next is we have, it will end on 16. Okay. Very simple, because for scan, so it is most likely in ascending order. So we only have 2 lines. Again, if you're going to do the subtraction per segment, 82 minus 50, 140 minus 82, then 170 minus 140, so 1, 2, 3, 4, 5, 6, 7, 8. You have 8 segments for subtraction, but then as I've said, the easiest way for it is we have, again, let's have the total seek time or the total head movements. So to calculate the total head movements for scan, it's very easy because you only have 2 lines. So what we're going to do is we have 199 minus 50. 199 minus 50 is we have 149. And then the next line, which is 199 minus 16, is we have 183. And then we're going to add. So we have 9 plus 3 is equals to 12, 2 carry 1. Then 8 plus 4 is 12 plus 1, we have 13, 3 carry 1, and then 1, 2, 3, we have 332. Total seek time or the total head movements by using scan in the about this scheduling algorithm. Okay, we can compare. So for this, for the Fcfs and scan, as you can see, there's the value in scan is significantly lower than the Fcfs, almost half. Okay, so that is scan. Okay, next is, last but not the least, let's go with the third disk scheduling algorithm that is commonly used, which is the C-scan. Okay. So we have C-scan. Okay. It is really very similar with scan, but the only difference is that you'll see in the example why it is called the circular scan. It's also an elevator algorithm, but this circular, this C here, that made its difference, very different with scan. So again, allow me to draw again the number line for the values for the cylinders. So we have again number line for that. Okay, so we have 0, then we have 199. Again, the values is we have 16, we have 24, and then next is we have 43, and then we have 50. Okay, next is we have 82, and then 140. Next is we have 170, and then last but not the least is we have 190. Okay. So for C-scan, so just the same with scan. Let's get back with our problem. So it also uses this term. It is also given that the disk arm should move towards the larger value. So let's take that to consideration. So again, the current request is at cylinder 50. So in ascending order, so larger values than cylinder 50 is 82, 140, 170, 190. So let's just fulfill the requests of those cylinders. So we have 50 to 100 to 82. Okay. Then next is we have 140, and then next is we have 170. Okay. Next is 190. And then just the same with scan, it will go to the end of the disk, which is 100. For this example, we have 199. So, what's the difference with scan and C-scan? So, since it is called circular scan, from 199, it will go to, instead of going to the nearest values, the remaining values is 16, 24, and then 43. It will travel going to the other end. So, from 199, it will go to 0. So, that's the difference with C-scan. So, that is why it is called circular. So, from this end, 199, it will go to the other end of the disk, which is 0. Okay, then it will continue to serve 16, 24, 43. So, we have, okay, going to 16. Okay, then next is going to 24. And then last but not the least, going to 43. So again, the notable difference between C-scan and scan is that, of course, why it's called circular, because from the end of the disk, it will travel to the other end. So this is the notable difference between C-scan and scan. So we're already finished. We've already served all the cylinders that has a request. So let's compute the total seek time or the total head movements. So for easier computation, just one line, 199 minus 50, then 199 minus 0, and 43 minus 0. Instead of, again, per segment. So we have our first line here is we have 199 minus 50 is we have 149. Next is 199 minus 0, of course. 199 minus 0 is equal to 199. And then last is we have 43 minus 0. 43 minus 0 is we have, of course, 43. So let's add these three values that we have acquired from the graph of C-scan. So 9 plus 9 is we have 18 plus 3 is we have 21, 1 carry 2, then 2 plus 4 is we have 6 plus 9, 15 plus 4 is we have 19, so 9 carry 1, so 1, 2, 3, so we have 391 the total seek time or head movements for C-scan. So let's compare. So of the three, which is the best disk scheduling algorithm for this example? So let's go back with our values for Fcfs and scan. So for Fcfs, it's 642. It has the highest value. While scan is we have 332. So with C-scan is we have 391. So which of them is the best with regards to the example? So for this example, the best scheduling algorithm here is of course the scan because it has the smallest total seek time or head movements. So the question here now is it always the scan the most the best this scheduling algorithm? So actually it depends upon the sequence and of course the sequence of the cylinders. So so for this example, the best here is the scan disk scheduling algorithm. So I hope that you've learned about this disk scheduling algorithm again. So we have the first come first serve. So first come first serve is depending on the sequence of the or the order of the cylinders that is to be serviced for its requests. And then we have the scan, which is from the current position, and then depending on the problem, so you have to identify where the direction of the disk movement will go. Will it be to the higher value or to the smaller value? So with regards to the problem, you have to read between the lines. You have to understand where does the head or where was the read and write head going? Is it going to the higher value or to a smaller value? And then of course for C-scan is the difference is that going to the other end of the disk, it will go to the other side. So for this example, we have 199 going to 0. So if you do have any questions, so please feel free to comment below. And I hope again that you've learned something from this lesson. So the disk scheduling algorithms, as I've said, there are many disk scheduling algorithms that exist, but then again, only those three, the Fcfs, the scan, and circular scan are the most commonly used because it will not cause starvation for the request of cylinders. So again, don't forget to subscribe to my YouTube channel. So thank you very much and good day and stay safe.